to understand how rainbows work, we first need to look at how sunlight interacts with raindrops. Now, if you take rain and if you take an individual raindrop, it will look like this in the shape of a teardrop. But then, for all practical purposes, we can approximate it to be the shape of a sphere. All right? Okay, now, let's say I had a large spherical droplet of water over here. And for the sake of simplicity, let's say I have an incident ray at some random angle like this. And also let's assume that this incident ray is of red color. It's red in color. Okay? Now what would happen? Now this ray is traveling from air to water, which means that it will bend toward the normal, right? That's simple. So it will refract. Now if you follow that refracted ray, it will reach the other side and it will reach an interface where it's moving from water to air. So therefore it will refract again. But then I'm not concerned about that. I'm concerned about another phenomenon that takes place over there. It's called partial internal reflection. So most of the light will get refracted and some of the light will also get partially reflected back inside. So let's follow that reflected ray. So we follow the reflected ray over here, then this ray reaches another interface where it's moving from water to air, right? Therefore, it's going to get refracted again, right, in such a way that it will bend away from the normal. So, of course, there is partial internal reflection that takes place over here, but we're not worried about that. I'm only worried about the refraction in this case. So there are three important phenomena that we need to be worried about or concerned about. The first is refraction, then partial internal reflection, then refraction again. Okay? Now, the interesting thing is, if I had a bunch of, let's say, parallel red rays, all incident at the same angle over here, there will be multiple refracted rays and multiple emergent rays that come out in the side. But it's interesting to note that at an angle of 42 degrees, the intensity of these rays will be maximum. I repeat, at an angle of 42 degrees with the incident rays, the intensity of the emergent rays will be maximum. So for all practical purposes, we can assume that all the light is coming out at 42 degrees. So if I had a bunch of rays of red color incident at this angle, then the emergent rays will all come out at 42 degrees. Now instead of red light, if I had violet light, right, I had a ray of violet light that's incident at the same angle, what would happen? Well, we all know that the refractive index of a medium is different for different colors. So therefore, the angle of refraction will be different, right? So it'll bend at a different angle, it'll come out at a different angle, and therefore the final emergent ray will also be at a different angle, right? But what's interesting to note is that the maximum intensity occurs at 40 degrees for the case of violet light. So if I had a bunch of parallel violet rays all incident at this angle, the final emergent ray will be at an angle of 40 degrees. So the angle of deviation, you can call this angle the angle of deviation, is basically, okay, let's call it delta. This angle is delta, and the delta for violet light, we find experimentally, is about 40 degrees. So 42 degrees for red light and 40 degrees for violet light. And of course, I mean, it's pretty easy to understand that the angle, the delta for all the other colors, right, the colors between violet and red, will all be in between 42 and 40. So then you should be able to answer what will happen if instead of violet or red, I had a ray of white light or a bunch of rays of white light incident at this angle. You'll find that all these rays split up, come out, and then finally we have red light coming out at 42 degrees, violet light coming out at 40 degrees, and all the other colors, indigo, blue, green, yellow, orange, and red, all of them in between. Now comes the beauty of the sphere, because the sphere is symmetric in all directions. What I mean is, if instead of having a single ray of red light at some random angle like this, let's say I had it coming in horizontally like this, then the emergent ray will come out at an angle of 42 degrees. This we know. But then it will symmetrically come out above as well, right? There'll be another ray that comes out at an angle of 42 degrees. Now, if you think about it, these two will not be the only rays. There'll be infinitely many rays, right? Because there are infinitely many planes in which this will happen. So if I turn this sphere like this, in every single case, there'll be an angle, there'll be a ray that's coming out at an angle of 42 degrees.